So welcome back to maths class, and now we will talk about from where we had stopped. We were talking about lines and angles, and till now we had covered the introduction, the basic terms and definitions, intersecting lines and non-intersecting lines, then pairs of angles, and then finally we talked about parallel lines and transversal. And in this class we will talk about lines parallel to the same line and how to use this for solving questions, and finally the angle sum property of a triangle. Right, now let's start off with our topic, lines parallel to the same line. Now here you can see we have three lines parallel to each other, right, and a transversal shown in red color cutting the three lines at some points, right, and the angles they make are angle 1, angle 2 and angle 3. These are the three angles they make with the line, right, these are the three angles they make with the lines. Now as these lines are parallel to each other, you can see angle 1 must be equal to angle 2. Why? Because the two lines are parallel, and angle 1 must be equal to angle 2, right, and angle 2 must also be equal to angle 3. Why? Because the next two lines are also parallel to each other. Or in other words, we can say that if more than two parallel lines are there, the corresponding angles should also be equal for every set of lines, and this is also correct for all the other types of angles: alternate interior angles, alternate exterior angles and co-interior angles. This statement is true for every angle, every pair of angles on the parallel lines. And here, as I have told you, you can see angle 1 equals angle 2 and angle 2 equals angle 3, and therefore we can say angle 1 is also equal to angle 3, right. So for every parallel lines, all the sets of angles, all the different types of angles that we had talked about will always hold correct, right, will always be correct. And for the interior angles, this angle must be equal to this angle, right, and this angle must also be equal to this angle, because these two are interior angles and these two are exterior angles. And like this you can get all the different angles for as many parallel lines given to you. There may be hundreds of parallel lines given to you, and it will be very easy to find all the angles, because you can identify two pairs of lines, you can identify a pair of parallel lines and get the angle, the different types of angles for the set, and extend this rule for every pair you get as you move down, right. So in a simple statements, we can tell lines which are parallel to the same line are parallel to each other, right. For example, here in the given statement, given figure, the first line is parallel to the second line and the second line is parallel to the third line, and therefore we can tell the first line is parallel to the third line, right. And in this way we can extend this rule for any number of parallel lines given to us. So in this small example we have learned that for any number of parallel lines given to us, we can get the measure of all corresponding angles, or all the alternate interior angles, or all the alternate exterior angles, and so on, right. So let's apply this rule to a question and find out what or how we can apply this rule to the questions to be solved. Now in this given figure, the question says if PQ parallel to RS, or the given line PQ is parallel to RS, and the given angles are angle MXQ is 135 degrees and angle MYR is 40 degrees, Then we have to find the angle of the measure of the angle of XMY. XMY, which is this angle. This is point M. Right? This is not given in the figure, but this is actually point M. It has not come. So this is point M, and we have to find out the measure of the angle XMY, where we are given angle MXQ is 135 degree and angle MYR is given as 40 degrees. So let's see how we can do this. So what we do one construction. We draw a line parallel to PQ and RS passing through M. We draw a line parallel to PQ and RS passing through M and call it AB. The line AB is constructed by us such that it is parallel to the given lines. And why have we done this? Because you can see angle XMY, the angle is such that we cannot calculate it directly. There is no kind of interior angles or no kind of corresponding angles. We cannot find them directly, right? So for that reason we have drawn a parallel line such that we get segments of transversal for every set of parallel lines. And here you can see for the first set we have got XM as a piece of transversal for the parallel lines PQ and AB. For the next set of parallel lines AB and RS, we have got a piece of transversal MY, and this is how we can get the measure of angle XMY very easily, because in here we can easily get the corresponding angles or the alternate interior angles and many more types of angles very easily. So how do we do it? Angle MXQ and angle XMB are interior angles, and which are they? Angle MXQ, this angle 135 degree, and angle XMB is this angle. You can see these are interior angles or these are co-interior angles, right? As these are interior angles, they must be supplementary, or angle MXQ and angle XMB must add up to 180 degrees, and we are using this here to find out the value of angle XMB. So 180 degrees minus angle MXQ must be angle XMB, right? So 180 degree minus 135 degree is 45 degree, or angle XMB comes out to be 45 degrees. Okay, so we get the value of half of the angle, right? For the upper half of the angle we get the value. Let's find out the value for the lower half of the angle, and then what we will do is we will add them up. So for the lower half, angle MYR, which is this angle 40 degrees, and angle YMB, which is this angle. These are, as you can see, this angle and this angle are alternate interior angles, right? And alternate interior angles are always equal, and therefore this angle must be 40 degrees as well, right? So the upper angle we had got 45 degree, we have got this angle as 40 degree. So I think now it is very easy to find out what is the total angle or angle XMY. So we have got angle XMY as XMB plus angle YMB, right? This was 45 degree and this was 40 degrees. So this total angle came out to be 85 degrees, and this is what we had wanted. Angle XMY is 85 degrees. So you can see we have used the concept of more than one parallel lines. Here the parallel lines are PQ, AB and RS, and we have used these three parallel lines to get the value of the bigger angle XMY. right? So here are the steps once more. First, we had constructed a line AB so that we get individual segments of transversal, because we wanted to see the interior angles or the corresponding angles, right? We wanted to see these angles more easily, because if there is one transversal, we will get these angles in just one step. So what we did, we got the interior angles as angle MXQ and angle XMB, and we got the value of angle XMB as 45 degree. By the rule, the interior angles add up to 180 degree, right? And for the next set, for the next half of the parallel lines, what we did, we found out the alternate interior angles, and in this way we found out the value of angle YMB, and we added angle YMB and angle XMB to get the angle XMY. So from this method you can see it is very easy to use the more than one parallel lines to get simple solution of any questions, right? And let us look at one more example. In the given figure, PQ is parallel to ST. PQ is parallel to ST, and angle PQR, you can see it is 110 degrees, and angle RST, it is given as 130 degrees. Now you have to find angle QRS, and this is also a similar kind of question. You can see we have to find this angle, but in no way you can see either it is a corresponding angle or it is a co-interior angle or it is something else, right? Directly you cannot find out. So this question needs some construction. So what we have constructed, again we have constructed a line AB, but now here we have constructed it such that it passes through the point R and is parallel to PQ and ST. AB is parallel to PQ and ST. So we have got three parallel lines, more than two parallel lines, and we are going to use the concept once again. So what you can do is angle RQP, angle RQP is 110 degrees, which is equal to angle QRB. And why is it so? Because they are alternate interior angles. You can see if we consider PQ parallel to ARB, if these were the parallel lines, angle PQR must have been equal to angle QRB. Forget about the line RST, forget about what is RST. So angle Q should have been equal to angle R, right? 110 degrees. So this full angle must be 110 degrees, because they are alternate interior angles. So let's move on. Now we have got this angle as 110 degrees, right? But we need only this angle, right? We don't need the extra angle. So we need to eliminate this angle. But what is this angle? This is co-interior to this angle, right? This angle is co-interior to this angle. So what we can do, you can see here this angle is co-interior to this angle, which is only this part. So this angle must be 180 degree minus 130 degree, which is 50 degrees, right? This one must be 50 degrees. So I think you have got this one as 110 degrees because they were alternate interior angles. This angle only you had got as 50 degrees. So how much is this part? This part is this full angle minus this small part which is not needed. So 110 degree minus 50 degree gives us this angle, which is 60 degrees, right? Now what we have done, we have found out angle QRB and angle SRB, right? We have found out angle QRB and angle SRB, and we subtracted them to get the value of the angle we needed, which is this one, which came out to be 60 degrees, right? Because angle QRS plus angle SRB will add up to angle QRB. Why? Because they are adjacent angles. So here we have used the concept of more than two parallel lines, and we have used the concept of the corresponding angles. We have used the concept of alternate interior angles, co-interior angles, and we have used the concept of adjacent angles also. So let's move on. Let's talk about the angle sum property of a triangle, and I think you know this theorem well. The sum of angles of a triangle is 180 degrees, right? Now how do we prove this theorem? How do we prove this theorem that sum of angles is always 180 degrees? Here also we use the concept of parallel lines, and we need to do some construction. So let's do it. So what we have done is, yes, we have drawn a straight line parallel to BC. Consider this line to be straight and parallel to BC. I know it is not looking as such as parallel, but consider this as parallel lines. The line which I have drawn is parallel to the base BC, right? And so if you take the two parallel lines, this line and base BC, you will see we have two transversal, which are AB and AC. We have these two transversals. So let us take our first transversal. Okay. So let us take our first transversal, which is AB. So you can see angle B must be equal to this angle, right? These two angles must be equal. Why? Because they are alternate interior angles. So this angle must be B. And similarly, if we take AC as the transversal for the two parallel lines, we will have angle C equals to angle equal to this angle, which we can also call as angle C, because these two are equal, right? So you can see all the angles A, B, C are lying on the straight line, and if the angles lie on a straight line, they must add up to give a straight angle, which is 180 degrees, right? So what we have done here, first we have constructed a parallel line which is parallel to the base BC. Then we have got the alternate interior angles for angle B and angle C, right? And we have seen that all the angles are lying on a straight line. All the angles are lying on the straight line, and therefore these three angles, angle A plus angle B plus angle C, adds up to 180 degrees. Now if I remove all this, you can easily say that angle A plus angle B plus angle C equals 180 degrees, and actually we have proved this theorem, right, by using a parallel line parallel to BC. So let's look at one more theorem. If a side of a triangle is produced or extended, then the exterior angle so formed is equal to the sum of the two interior opposite angles. Now which are the interior opposite angles? If this is the exterior angle, you can see the side QR has been extended to S, RS is a ray, right? So if angle 4 is a exterior angle, then the two opposite interior angles are angle 1 and angle 2. And this statement and this theorem tells us that angle 4 must be equal to the sum of the two opposite interior angles, which is angle 1 plus angle 2, right? 4 must be equal to angle 1 plus angle 2. I think you also know this, but still let us prove this theorem so that you get to understand why this statement is always correct. So we know angle 3 plus angle 4 must equal to 180 degree because they are lying on the same line QRS, right? They are lying on the same straight line. So these two angles must add up to 180 degrees. And we also know from the earlier theorem all the angles of a triangle must add up to 180 degree also. Angle 3 plus angle 2 plus angle 1 must also add up to 180 degrees. So what we can do is, you can see angle 3 plus 4, the value of angle 3 plus angle 4 must be equal to angle 3 plus angle 2 plus angle 1, right? The sum of angle 3 plus 4 must be equal to the sum of angles 3 plus 2 plus 1. So what we do, we make them equal. We make them equal, and thus you can see 3 gets cancelled off from both the sides because they are all in addition form. 3 gets cancelled off from both the sides, and finally we arrive at the result angle 4 plus angle 2 angle 4 equals angle 2 plus angle 1, right? So we have proved that the exterior angle is equal to the sum of the two interior opposite angles. So angle 4 equals angle 2 plus angle 1, and this is true for any triangle, right? So let's move on and try to apply these theorems and the theorems we had learnt in the earlier classes to some questions. And here is one question. In the given figure, if the lines PQ and RS intersect at point T such that angle PRT equals 40 degrees and angle RPT equals 95 degrees and angle TSQ is 75 degrees, find angle SQT, which is this one. We have to find these angles when these values are given. Now how do we proceed? You can see these two angles are vertically opposite, right? These two angles are vertically opposite to each other, so these two angles must be equal, right? And how do we get this angle? From the sum of the angles being 180 degrees. So 180 degrees minus the sum of these two angles should give us this angle, right? Because this angle plus this angle plus 95 plus 40 is 180. So if we subtract the sum of these two angles from 180 degrees, we will get this angle easily, and this angle will be equal to this angle. And finally we will apply the same law here. We know this angle, and we need to find this angle, and we will find it by using the same thing. Sum of angles in a triangle is 180 degrees. Now let's see how we proceed in this way. So you can see we know that these two angles are equal, and you can find out the value of this, right? You can find out the value of this very easily. Angle SQT is angle TSQ, which is 75, plus, this should be plus, because we are subtracting the sum of the two known angles from 180 degree to get the third angle, right? So angle SQT is 180 degree minus the sum of the two remaining angles, which is this 75 and the one which I've got from the earlier this side. We have got from this side, this is the value. We know these two values, right? And so after calculating this, you will get the value of SQT as 60 degrees. And let's see what is the value of this one. So the sum of these two angles is 135 degrees, right? The value of this angle is 135 degrees. So this is also the same for oh no, this angle, the value of this angle is not 135 degrees. The sum of angle P and angle R is 135 degrees, and if you try to calculate this angle will come out to be 45 degrees. This angle will come out to be 45 degrees. So you can see angle P plus angle R will give us 135 degrees, and if we subtract 135 degrees from 180 degrees, we will get angle PTR as 45 degrees. Similarly, angle STQ will also be 45 degrees because they are vertically opposite. And then we subtract the sum of angle STQ and angle TSQ from 180 degrees to get SQT as 60 degrees. In a similar fashion, we can get the value of angle Q as 60 degrees. And let us do one more question. Right, let us do one more question to see this. In this figure, the sides AB and AC of triangle ABC are produced to points E and D respectively. You can see they are extended to E and D. If the bisectors BO and CO of angle CBE and BCD respectively meet at point O, then prove that angle BOC equals 90 degree minus half of angle BAC. Now let me simplify the question for you. BO is the bisector for angle CBE, right? BO is the angle bisector for angle CBE, and that means this angle is equal to this angle. As it is an angle bisector, that means it divides the angle into equal halves. Angle CBE has been divided into equal halves, and you can see it is marked with one single line that this angle is equal to this angle, right? Angle CBO is equal to angle OBE, right? Similarly, CO is a bisector of the angle BCD, and therefore you can see there are double lines here which indicates that angle BCO is equal to angle OCD, right? They two are equal. And also you can see that this angle is represented with a single line, but here we have double lines which says that angle OBC is not equal to angle BCO. These two angles may or may not be equal, which is not stated in the question. So here we are taking that these two are not equal, which is the extreme case, right? So let them be not equal. So what we have got is, we have got the angle bisectors and the angles we have got, and here the measures of the angles ABC are written as X, Y and Z respectively. Now let us see how do we proceed. So what is the value of angle OBC? Angle OBC equals half of 180 degree minus Y, and how do we get that? Let us see. Angle OBC, or this angle, we need to get this angle. So what we do, first we find out the value of angle CBE, the full angle, right? This value of the full angle, which is nothing but 180 degrees minus this angle Y, right? 180 degree minus this angle Y. So we get this full angle as 180 degree minus Y. So what should be half of this angle? It should be half of 180 degree minus Y, right? So we have done that same thing. Half of 180 degree minus Y we have taken as angle OBC. And similarly, to find angle OCB, or only this part of the angle, we first find out this entire angle, which is nothing but 180 degree minus z. 180 degree minus z gives us the angle BCD, right? Because angle Z and angle BCD lies on the same straight line. So 180 degree minus Z gives us angle BCD, and to get half of the angle, we take half of 180 degree minus Z, and this gives us the value of this bisected angle OCB. Okay, so we have got the value of this angle, also we have got the value of this angle. Now we need to find the value of angle BOC, right? In the question we are asked to find the value of BOC and show that it is equal to something. So first we need to find the value of BOC, and we know two of the values of this triangle BOC, right? So what we do, we use the sum of angles of a triangle as 180 degrees and subtract the sum of the two angles. We subtract the sum of the two angles from 180 degrees and get the third angle, and we do that same thing here. Angle BOC equals 180 degrees minus angle OBC plus angle OCB, right? Angle OBC plus angle OCB. Here 180 degree minus sum of these two angles will give us angle BOC, right? Because these three angles must add up to 180 degrees. Now if you put these values, in this equation, if you put these two values in this equation, you will finally end up with y plus z by 2. You will finally end up with this value y plus z divided by 2, and we can write this as 180 degree minus x. Why? Because if we want to get x, we need to subtract y plus z. We need to subtract the sum of y and z from 180 degrees, right? Because x plus y plus z equals 180 degree. Therefore y plus z must be 180 degree minus x, right? 180 degree minus x will be y plus z. So here we replace y plus z in terms of x, because our equation is asked in terms of x only, which is angle BAC, right? Angle BAC is x, and we have been asked to find angle BOC in terms of x, right? So what we obtain from here is, we just separate the fractions out. 180 degree minus x by 2, we separate the fraction out and get 180 degree by 2, which is 90 degree, minus half of x, right? 90 degree minus half of x, which is nothing but 90 degree minus half of angle BAC, right? So let me repeat the steps once more. First what we did, we observed this triangle BOC. We observed this triangle BOC and tried to find out the value of this angle and this angle by using whatever value is given here, the value of y and z, right? Because they all were lying on the straight lines. So we did 180 degree minus y to get the value of the full angle, and then as it has been bisected, we make it half to get that value of the angle we need to find. And similarly we do it the same thing at angle C, right? We do 180 degree minus z and make it half to get the value of the bisected angle. And you can see these two bisected angles, when added up and subtracted from 180 degree, must give us the value of the third angle, which is angle O, right? So we get the value of angle O as 180 degree minus angle OBC and angle OCB. By putting in the values and calculating it, we end up with the value y plus z by 2, and y plus z can be written in terms of x as 180 degree minus x, and therefore by calculating the term further we end up with the result we want, which is 90 degree minus half x, or 90 degree minus half angle BAC. And actually you have seen we have not used the formula for exterior angles here, and you can use the formula for exterior angles here also. And how to do that? This angle must be x plus z, right? This angle must be x plus z. So the half of this angle must be x plus z by 2, right? This angle will be x plus z by 2. This angle will be x plus y because it is exterior angles. This angle, whole angle, will be x plus y. So half of this angle, only this angle, will be x plus y by 2, right? Now in a similar fashion you do 180 degree minus x plus z by 2 plus x plus y by 2, and finally you get the value of the third angle, which is angle O. You can get it very easily by replacing x plus y plus z with 180 degree, and you will see only one x is left out, and ultimately you will end up with the same expression, which is 180 degree minus x by 2, and ultimately you will get 90 degree minus half x. So you can see we can solve a question in different fashions by either using the sum of the angles of a triangle is 180 degrees simply, or along with that we can use the theorem of exterior angles that we have learnt, right? It is very easy to use, and you can solve any question based on these two theorems very easily for any kind of triangles, right? So these were the small topics to be covered here. I think you have got an idea of that. So in this topic, in this class, we have talked about the topics lines parallel to the same line, and finally the angle sum property of a triangle, right?